I'm going to work through the quiz for 6.2 just to show you my thought process on how this works, and hopefully this will help you with the retake if you are taking it. So with U substitution, generally what the inside function is what I'm going to let U equal. So x squared plus 6, take the derivative or the differentials of both sides, you get that. So converting that over, that is U squared. X dx also has to be converted, so x dx is right there, so I'm going to bring that 2 over here, and I now have 1/2 du. So I'm going to put the 1/2 out front just because that's what I like to do. Right now I can't put 0 and 1 there. If I want to put x equals 0 or x equals 1, that's fine, but everything needs to be converted into u's or be stated otherwise. So I myself am going to let x equal 0 here, and then find out what u is. So 0 squared plus 6 is 6. Plug in 1. 1 squared plus 6 is 7. So now it becomes a definite integral problem. I take the antiderivative by adding 1, multiplying by the reciprocal, so I have 1/2 times 1/3 of 1/6. And I'm going from 6 to 7. We got to be careful on our notation here. Plug in 7. Plug in 6. And subtract. 7 cubed is 343 over 6. 6 cubed times 1/6 is 36. So we get, I believe, 127 over 6. Over here, inside function would be that, so I'm going to let u equal 4x squared minus 5. So du is 8x dx, which is good because I already have that there. So that is u cubed in the denominator. So when I convert it, I'm going to make it u to the -3. And I have 8x dx. 8x dx, that's the same as du. And now I can take the antiderivative. Because that's an indefinite integral, and that's what it's asking for, is the antiderivative. So I'm going to add 1. Multiply by the reciprocal, and then put a plus c. It is not the work if we leave it in terms of u. Everything, the original problem was in terms of x. Converting to u is just a helpful way to get there. So we need to convert back. U is the same as 4x squared minus 5. Here our inside function is x cubed, so we're going to let u equal x cubed. Du is then 3x squared dx. So converting it, I've got cosine of u. Now I've got x squared dx. X squared dx I can rewrite as equal to 1/3 du. So I'm going to substitute that in there. So I've got my 1/3 du. Leave the integral sign. So now I'm actually going to take the antiderivative. What is the antiderivative of cosine? Well, it is sine. Sine of derivative of sine is cosine. So I have the 1/3 out in front. I've got plus c, and then convert back to x's. Over here, I've got an inside function of ln x. So let u equal ln x. Du is the same as 1 over x dx, which I have already. X is in the denominator, x is in the denominator, dx, dx. So I'm going to convert. Square root of ln x becomes square root of u. That x in the denominator, dx, is the same as du. And I'm going to not put 1 and 5 because those are in terms of x. So if I wanted to put x equals 1 and x equals 5, that's fine. But don't put 1 and 5 because it's not mathematically correct. Okay, so I'm actually going to convert. That's my favorite method. So ln of x, x is 1, so ln of 1 ends up being 0. X is 5, ln of 5 is an irrational number. So now it becomes I need to take the antiderivative. I'm going to rewrite it first, and then plug in my numbers. Square root of u is u to the 1/2, so now I'm going to take the antiderivative. I'm going to add 1, multiply by the reciprocal, and then go from 0 to ln 5. So we've got 2/3 ln 5 to the 3/2 minus 2/3 0 to the 3/2. plug in the top number, plug in the bottom number, and subtract. That becomes 0, so that is my answer. For some reason, I saw a lot of people doing this. ln of 5, not for sure where that came from because I've never seen that before, but I suppose that would be okay. Just got me curious. All right, next up, level 4 obviously got a little bit harder. We're looking for what u would be. Since it's e to something, I'm going to try to let u equal sine of 5x. So du, notice I've got an outside and inside function, so we're going to have to use the chain rule. Derivative of sine is cosine, leaving the inside alone, times the derivative of the inside with the dx there. Which is good because that part of it is already in my integral, so we'll just keep going here. Convert over. I've got e to the u in the denominator, so I'm going to bring that up as e to the negative u. Cosine of 5x dx, cosine of 5x dx. I'm going to bring the 5 over with the chain rule. A lot of people did on the assessment forget the chain rule. So that is 1/5 du. Now I got to take the antiderivative. Antiderivative of e to the negative u is negative e to the negative u. And I've got that 1/5 out front as well, and then a plus c. So negative 1/5 e to the negative, and then u was sine of 5x plus c. And the last one, sine of ln x over x, integral of that. So if we let u equal ln x, du, if you remember the derivative of ln x is 1 over x, which already was there. So converting over, sine of ln x becomes sine of u, x dx, and the x in the denominator is what we have, so that's just du. We've got the integral of sine, and an antiderivative of sine is negative cosine. I need a plus c because it's an indefinite integral, doesn't have the limit, so we've got negative cosine of ln x plus c.